Hello everyone, welcome back to our YouTube channel. Today we will learn about ordinary least square regression using Eviews. Before starting the analysis, you must know what exactly is OLS regression and why it is widely used. Ordinary least square is a method in statistics used to estimate the coefficient of a linear regression model. It's a powerful tool for understanding the relationship between variables and making predictions based on historical data. OLS regression is cornerstone of statistical analysis. It is employed in various fields from economics to finance, and it's essential for anyone looking to find the relationship between dependent and independent variables. Here in Eviews, I have loaded a data set which is actually time series data. As you can see that these all are the variables in our data set. As there are total 19 observations from the time period 2005 to 2023. Now you need to select all these variables for which you want to run the OLS. So first select your dependent variable. Here in this study, GDP is our dependent variable and other three variables are exchange rate, inflation rate and interest rate. And then open these variables as equation. So you can see here the first one is the dependent variable and other three variables are independent variables like exchange rate, inflation rate and interest rate. Whereas C, which is the constant over here. Now let's run simple OLS regression. You can see here in the method section, numerous methods are available for running regression analysis. But we need to run OLS regression. Click on the least square method and our sample is from 2005 to 2023. Now click OK. You will get the output or result for the OLS regression. C is the constant. Here we have coefficient value, standard error, t statistics and probability value. In the coefficient section, C is the constant which shows the average value of dependent variable when all other variables are equal to 0. Likewise, you can also look at the value of R square. R square actually shows the fitness of the model. Here R square value is 0.94, which means that 94%. Likewise, you can also look at the R square value which is 0.945 or 94%, and the adjusted R square is 0.93 or 93% for this data set. You can also see the F statistics which is 0.00. Now, how do we interpret the result of our OLS regression? As you can see, while reporting your results, you need to look at probability value, R square value and F statistics value. First, look at the probability value for some particular variables. If it is less than 5%, it means that there is a significant positive or significant negative relationship between IV and DV. You can see that in this output we have our dependent variable is GDP and the three independent variables are ER, exchange rate, inflation rate and interest rate. So first, looking at the result of exchange rate, the coefficient value is 0.011 and its p-value is less than 5%. So it means that there is a significant positive relationship between GDP and exchange rate. If there is a 1% increase in exchange rate, GDP will increase by 0.011% or unit, and there is a positive relationship between these two variables because its p-value is less than 5%. And now our second variable is inflation rate. Its p-value is greater than 5%, means that This variable have insignificant relationship with our dependent variable, that is GDP. Now looking at our last variable, interest rate, its p-value is less than 5%, that is 0.0168 or 1.68%. Now looking at its coefficient, which is minus 0.0062. So this means that a 1% interest rate GDP will decrease by 0.0062 unit or percent, because there is a significant negative relationship between interest rate and GDP according to this data set. By this manner, you can interpret your regression coefficients. You can also determine the direction of relationship between independent variable and dependent variable, and also determine whether the relationship is significant or insignificant relationship. In order to find the direction of relationship, negative or positive, if the coefficient have negative sign, it means that there is a negative relationship between this variable with its dependent variable. So you can also look at the R square that actually shows the model fitness. As for our data set, we have R square value of 94%, indicating that 94% of the variation in the dependent variable is being caused by these independent variables. Then we may interpret the probability of F statistics, which is 0.00. It indicates the robustness of the entire regression model. So this value is also less than 5% level of significance. So overall, in this data set, we can say that one variable have significant relationship, one variable have insignificant relationship, and one variable has significant negative relationship. R square and F square values also supported our result. So this is how you can run an OLS for a time series dataset, and this is how you can interpret your results and report your results accordingly for your particular dataset. If you found this tutorial valuable, don't forget to like, share and subscribe. Thanks for watching.